Is this thing on? Okay. So, good day to all of you. Uh, it's been a while since my last broadcast for a long time. So, I am just here today to share to you one interesting problem that I've got from one of my clients in my tutorial. So, last time, uh, I just given some mostly geometry problems uh, from the last video that I made. This time, I'm going to share to you an algebra problem that is quite interesting at the first glance because this involves special products and factoring. But mostly the essence of this problem is more on factoring. Okay? So the problem goes like this. The instructions expand. So we want to expand this expression. Uh, Square root of a plus b raised to the fourth minus square root of a minus b raised to the fourth. And not only that, once we expand this, we have to simplify. And in addition, there was an additional question that so this is the follow-up question. Upon expanding, find the value of 2.1 raised to the fourth minus 1.9 raised to the fourth. So I find this question enticing because it's a duality. Because after you solve this, you have to incorporate it with this question without using a calculator. Okay? So how do we solve this problem? Okay, let's focus first on this particular expression first. Okay, although the instruction says expand, it's not necessarily at that sense. We know for the fact that only a few people know the expansion for this binomial raised to the fourth. Majority of us knows the expansion by square of a binomial. So this does not look good. Okay? But there is another way to expand this even if we have limited knowledge on special products and factoring. Okay. So we can use this. The difference of two squares. And if we're going to extract this by factoring, that is in a form of this. So we're going to use this format, this question, just to downgrade the expression for a bit. And then once we downgrade it, that's the time that we can expand it in a more normal way. So we will first factor out these expressions. So this entire binomial is the x, and this entire binomial is the y. So it will look like this. Okay? Now, if I'm going to extract its factors, it will look like this. So it will be x squared plus y squared. Then, you will have x squared minus y squared. Take note, I allowed this as x and allowed this as y. So at least it's more tedious to factor. Now, if I have this one is a prime expression, so I cannot factor this further, but I can factor this portion here. So it will now be equal to x squared plus y squared. Then you have x plus y and x minus y. Now, bringing back to its original interpretation or representation, so we will allow x as this and allow y as this. So this now becomes square root of a plus b raised to squared plus this is square root of a minus b squared. And then for the rest of them, that will be times. This is now square root of a plus b plus this is square root of a minus b times this format. This is now square root of a plus b minus square root of a minus b. And now for the following expressions, this one, we can now express this as a square of a binomial. To do the square of a binomial, we square the first, we square the last, and then we multiply those two times 2. So it will appear as square root of a squared, and this is now plus 2 times square root of a times b plus b squared. Makes sense, right? And then we add for this one, that will be square root of a squared minus this is 2 times square root of a times b then plus b squared. So we already expanded this portion. Okay? So at least we expanded it in an easier way. Then for this one, times, this is now square root of a plus b, and then plus square root of a minus b. So upon doing that, so the b's will be eliminated because these are now opposite. And we will combine the square root of a's. Then multiply 2. This is now square root of a plus b. Okay, so that's here. Now, since this is preceded by a negative sign, these two expressions will change its sign. So you have negative square root of a plus b. So the two a's will cancel. 2 square root of a's will cancel out. So you will have 2 b's left. Now, observe this expression. Now, you may notice that this one is positive and this one is the negative of these same 3 expressions. Okay? So, this 2 will cancel out. Like so. Okay. So, since we already got that out of the way, this expression will now be simplified into So you have square root of a squared plus square root of a squared. So that is technically a. So a plus a, you have 2a plus this one's a b squared and a b squared. That will be a 2b squared. And then this is multiplied 2. Square root of a plus square root of a. So that's 2 square root of a times 2b. Okay? So it's much more simplified now. Then what do we do here? Okay. So your choice. You can multiply this first and then distribute it to these two. Or take out the 2 first and then make the distribution. So it's up to you. So, I guess multiplying this first will make it more practical. So, you will have 2a plus 2b squared multiplied to 4 square root of a and then b. I guess this one's a little awkward. We can't change this here. So we have 4b then a square root of a. Because it's a little awkward if I go with square root of a then b, since b is outside square root of a. Now, we distribute this expression to these two, and we will obtain 8ab square root of a plus 8b squared, that's b cubed, sorry. b cubed square root of a. And this is the expanded form of this expression. Kind of ingenious, right? So, you don't have to necessarily literally do the instruction. We can always bend it as much as possible to get to an expression that is easy to compute or easy to manipulate. Okay. Now, since we've already set this expression into this, we can now get to the second question. How can we reinterpret 2.1 raised to the fourth minus 1.9 raised to the fourth in the form of this? Okay? So first, we let 2.1 as square root of a plus b and 1.9 as square root of a minus b. So it turns out, it will look like this. So we have a system of equations. So in order to solve a system of equations, there's a lot of ways. We can use elimination or substitution, or some they use determinants. Okay, but for this particular question, we can use elimination to solve for both a and b, because that's the most practical way to do that. Okay, so for this question, we can do elimination by addition here to eliminate b. So our goal here is to solve for square root of a, or our target is solving for a. So b can be cancelled here, and then if I add these two square root of a, so we'll have 2 square root of a. And 2.1 plus 1.9, if we take this further, so this will result to 4. Okay? Now, our target is to solve for square root of a. So, if I divide this by 2, so our square root of a is equal to 2. So, we already now have a value to substitute it for these values, okay? But of course, for a, we take square on both sides. And that will result to A is equal to 4. Okay? Now, we've already have the value of A. We can now solve for B. Now, to make things practical, the first equation is easy to compute. So we can compute for B using this equation. So you have the square root of A, which is 2, plus B is equal to 2.1. So for B, we transpose 2 here. So you'll have B is equal to 2.1 minus 2. So obviously we can compute this one. So B is equal to 1/10 or 0.1. Now that our values are obtained, we can now use these for this expression. Quite ingenious, right? Take note, I'm not using a calculator for this problem. So, let's round them up. So, square root of A is equal to 2, A is equal to 4, and B is equal to 1/10. The value of this will be equal to, using this expression, 8 times A, which is 4, times B, which is 1/10 or 0.1, times the value square root of A, which is 2, plus, we have 8. This is now 1/10 or 0.1 cubed times 2. Pretty clever, right? So that's 8 times 8 times 2. So that will be 64 times 1/10. So we will end up with 6.4. Okay, we're getting close. Plus, this is actually 0.001, or that is 1 thousandths. And then we multiply by 8 times 2, which is 16. So that will give us 0.016 or 16 thousandths. And then we add these two. So you will have the value of 6 and 416 thousandths. Quite interesting, right? So, using this expression, in order to solve this expression, we obtain a value of this without using a calculator. Quite ingenious, right? So, that's our lesson for today. And thank you for watching. This is Megavinx, signing off.